Welcome to Pre-Calculus Honors.
Okay, so here are the steps. First, you make sure that the leading coefficient of the first variable in equation 1 is 1. All right, so usually that's going to be x. So in the first equation, the x term should have a coefficient of 1. Okay? Then you're going to eliminate the x term in equation 2. And you're going to do that by adding multiples of equation 2 with another equation. Then you're going to eliminate what's going on here? This should say y term. Hang on.
Welcome back.
All right. So make sure the leading coefficient of y in equation 2 is 1. All right. And then we go on to equation 3. In equation 3, we're going to eliminate the x term, and we're going to eliminate the y term in equation 3. And we're just going to be left with the z term, and then you have to make sure that the coefficient is 1. All right? So first, let's do this one. First, we're going to eliminate this x term, then this x term here, then the x and the y here, and we get, okay, row echelon form. All right. So what am I going to do here? Divide everything by 5. So divide the first equation by 5. And the way I do this is this. I always have brackets. And then I say, okay, so what we're doing is row 1, okay, that's row 1, divided by 5, or 1 over 5 times row 1, okay? That's the little notation that we're going to use. So here we get x minus y minus z is equal to 7. And this, we're just going to copy it over. Okay, let me make the z's clearer. Okay, so what we're going to do next is we have to eliminate the x term in row 2, okay? So in order to do that, now I'm going to use this system here. What I'm going to do is I'm going to replace row 2 with the sum of 1 and 2, okay? So here's what I'm going to do. Row 1 will stay unchanged, so I'm just going to copy that over. Row 3 will stay unchanged. Now, let's color code this. I'm going to add row 1 plus row 2, and I'm going to put it here. Okay? So if you add row 1 and row 2, what do you get? 0, I don't write that, well, maybe I will for now, plus y minus 4z is equal to negative 5. Make sense? Okay.
What if the x doesn't go away?
Well, that's the thing. You can also combine multiples, all right? So you can multiply 1 by 2 and add it to that, okay? All right. Next, so what I have now is this. Does that make sense? Yes. Okay, now, what else do I have to do? I have to make sure that the coefficient of the y term is 1, which it is, so I'm good with that one. Now here, I have to eliminate the x and the y, okay? To eliminate the x, you know what I'm going to do is I'm going to combine steps because I can do that. I'm going to erase this and replace it with something better. So what I'm going to do, what can I do to these equations here in order to make the x go away? Multiply this second one by 3. Well, and add it to this one, and it'll go away. Okay? So I'm going to do 3 times row 2 plus row 3. Okay? So 3 times row 2 is negative 3x plus this one is 3x, so 0. I'm multiplying this by 3 and adding it to this. So negative 3x plus 3x is 0. Now I multiply this by 3. 3 times 2y is 6y minus 2y is 4y. It's one of the things that I'm allowed to do. Add a multiple of one equation to another equation. And you can replace your equation. Okay? It's like the coolest thing in the world. So this is what we have Gauss to thank for. So we said we were going to get 4y here. Now, 3 times this one is negative 9z, plus this is negative 2z, equals 3 times negative 12 is negative 36, plus this is negative 6. Okay? Now, I can get rid of that one, so that's what I have. What I need to do now is I need to eliminate y at the very bottom. I need to eliminate the 4y. Okay, so eliminate 4y. How can I do that? So the first one is going to stay as is because I like what situation that's in. I like this one. Now, how can I get rid of the 4y?
Row 2 times 4 and then row 2 plus row 3.
Right. So I can multiply row 2 by negative 4 and add it to this one to get a 0 here. Okay? Negative 4y plus 4y. It's sort of like the elimination technique, right? But you just do it quicker. So let's use blue for this one. So negative 4 times row 2 plus row 3. What does that give us? Negative 4y plus 4y is 0. Hello. Negative 4 times this is 16z plus negative 2z is 14z equals negative 20 minus 6 is negative 26. Is that right?
Oh, no, isn't it 16? It's negative 4 times negative 5.
Oh, yes. So it's positive 16.
16,
Oh, and positive
14.
16. 14.
Positive 14.
Yo, Z is
Okay. So now let's just rewrite that. Huh? No, you're supposed to. So x minus y minus z is equal to 7. Y minus 4z is equal to negative 5. And now here, 14z equals 14, but I'm going to divide row 3 by 14. So it'll be 14, it'll just be z equals 1. It's 14z equals 14. It's hard to see, but it's 14z equals 14. Now, this is in row echelon form, okay? It's in row echelon form because the first one starts with the x, the second with the y, the last with the z, and each of the first variables have a coefficient of 1. So this is in row echelon form. Same thing, they're synonyms. Okay? Now, to solve, we're going to use what is called back substitution.
That's what we just did like before.
Yeah, back substitution means you have your z equals 1. Now you back substitute into this to get y, and then back substitute to get z. Okay? So, z is equal to 1, meaning y minus 4z equals negative 5 becomes y minus 4 is equal to negative 5. Y is equal to minus 1. And then x minus y minus z equals 7. X plus 1 minus 1 equals 7. So x is equal to 7. Okay? What does the answer look like? Anybody?
7, like you make it another matrix.
So the answer is in coordinate form. So x comma y comma z, meaning it's 7, negative 1, 1.
So we're allowed to finish these in coordinate forms?
You have to. So, okay, so when we did this, okay, we didn't really touch the x, the y, or the z, right? The only thing we worked with were the coefficients. You know, we worked with the 5 and the 2 and the negative 2 and the 30 and the negative 12. So really, the physical existence of x, y, and z is not even, like, it's just extra. You don't even need it. You don't need x, y, and z to be there. Well, that's exactly what we do. We get rid of the x and the y and the z, and we just keep the stuff that matter, the numbers, the coefficients, the constants. That's it, okay? So the system can also be solved using a matrix which lists only the coefficients and the constant terms, all right? So here was the equation, the system of equations that we solved. If I just take the equations, the coefficients and the constants, look, 5, negative 5, 35, it's these, okay? 3, negative 2, 7, 30, it's these, okay? What I create here is an augmented matrix. This has the coefficients and the constants. And if I just take the coefficients, it's conveniently called a coefficient matrix. All right? And now you can do the same exact thing that we did up there, but here with the matrix. You could interchange any two rows, multiply one row by a number, add multiples of one row to another, but without the, you know, the unnecessary x, y, z. Okay? And we can put it into row echelon form, just like we did over there. Remember what was row echelon form? We got rid of everything in the bottom triangle, and here everything was 1, 1, 1. And it's the same thing. It's like an identity matrix. Well, no, it's not. It's half of an identity matrix. Okay? But basically, what are the specifications? If to figure out whether something is in row echelon form, rows consisting entirely of zeros appear at the bottom. So here you have like a full row of zeros. You always have to put that at the bottom. The first non-zero entry is a 1, called a leading 1. And then for two successive rows, the leading one of the higher row is to the left. So basically it just looks like that. Okay, you just have to have an upper triangle. Yeah. Now, is this one in row echelon form?
No.
Why not?
Yes.
Well, it doesn't have to have zeros. If any. See, if any.
Yes.
Okay? So this is yes. What about this one? No.
Yeah, the blue line.
Because this has to be moved to the bottom. What about this one?
Yes.
Yes. Okay? So to get to this point, here are some tips and tricks. You start with the entry in the bottom left corner, so that one. Okay. Second, you eliminate A21, the one right, right above it, and then eliminate A32. So that's just how you start, and we'll start this tomorrow.